I just want to revisit a meta-analysis, how they work and how they might help us in a situation like this. So let's say you're trying to choose a hotel somewhere and you talk to one mate and they say that the Shangri-La is great. And then you talk to someone else and they say it's terrible, it was unclean, it was too expensive. But then you talk to someone else and they say, oh yeah, it was okay. I mean, when you've got those 3 reviews, you kind of don't really know what to do, right? Because you've got some people saying it's good, some people saying it's bad, some people saying it's all right. So what a meta-analysis does is it gets a number, an effect size from each sample, and then it helps us figure out what is the true value here. So with the hotel example, it'd be a little bit like getting a star rating, saying on TripAdvisor, what do you rate this hotel? So from 0 to 5, for example. And so your mate who said it was wonderful might give it a 5. The person who said it was terrible might give it a 0. And the person who said it was okay might give it a 2. Now we're closer to identifying what the true kind of star rating is for this hotel. So now what you can do is you can actually calculate an average of the 3 kind of reviews that you've got. So with our 5 and our 2 and our 0, we can add them all up, divide by 3 and say, well, this hotel's probably like a 2.3, which now allows you to get quite a definitive answer to how good it is. But what's even better is you can start to then do a meta-analysis and look at specific parts of the ratings. So on TripAdvisor, they rate things like cleanliness and the convenience, the location of the place. And you can now see, are all of them rating the same on convenience, or are they all saying it's unclean? And you can get an average for each one of the dependent variables, right? And one other thing which it allows you to do is what's called moderation, which is to say, well, look, these 2 people I actually agree with most of the time. That person who gave it a 0-star rating, I actually don't trust their opinion. And so you can just get an average of the ones that are rigorous kind of studies. And so you might say, well, average of 5 and 2, that's like a 3.5. I'm pretty happy with that. So the advantages of a meta-analysis are they allow us to get a definitive statistic that says how good or bad something is. Is it effective or is it not effective? And it allows you to quantify that using a number. Whereas something like a systematic review is trying to collate that good, excellent, okay kind of review. And the way it does that is by doing a mathematical equation that calculates an average of the effect sizes from all of the studies that are included. It weights that average so that the bigger studies, the more reliable ones, get more weight, and the smaller studies that are more prone to error get less weight. And the results we get at the end of a meta-analysis are a little bit like getting a definitive star rating on TripAdvisor, but with a little bit of error. And that allows you to do 2 things. The first thing it allows you to do is identify how big the effect is on an objective scale. So we'll talk about this a little bit later on, but most meta-analyses use one of 2 statistics. If it uses a Cohen's d, then it's basically saying a 0 means there's no effect, and a 1 means there's a massive effect. A 0.8 is big, a 0.5 is kind of moderate, and a 0.2 is a small effect size. And what this allows us to do is a little bit like 5 stars being perfect. It allows you to see how big the effect is on a fairly objective scale. When we're looking at correlational studies, the idea is the same, but the scale's a little bit different. So instead of going from 0.8 being big, 0.5 is big. So it's 0.5 is a large effect size, 0.3 is a medium one, and 0.1 is a small effect size. But we'll try to make that clear when we present the data about meta-analyses, about what we're talking about. The other thing that's really important that a meta-analysis allows us to do is to look at the error of that effect size and see whether it's significant. So if I told you that the effect size was 0.5 on a Cohen's d, then you'd say it's a moderate effect size. But as we know from all of our other statistics, we have to know whether that's a statistically significant effect or whether it could have just happened by chance. So the way a meta-analysis does this is it constructs like a confidence interval around that statistic, which means we think it's 0.5, but it could be anywhere between 0.2 and 0.8, for example. And the main thing to look out for here is if that confidence interval crosses 0. If it's like minus 0.3 to 0.8, then we'd say that, well, maybe nothing's happening. Maybe it's having a negative effect. We can't rule that out. The main thing to look for is, does the confidence interval cross 0? If it doesn't cross 0, then we'd say that it's a significant result. And then we can use that scale of effect sizes I talked about before to see whether it's small, medium, or big.